Welcome to Problems and Solutions. Today we will solve problem 8.1 of chapter 4 of Physics for Scientists and Engineers. A 20 kg block with a pulley attached slides along a frictionless lead. It is connected by a massless string to a 5 kg block via the arrangement shown in the figure here. Find the acceleration of each block and B, the tension in the connecting string. Okay, let's start drawing the free body diagram of each block. Here we have the block of 5 kg. Let's call it number 2 and number 1 to identify the blocks. So here we have block 1 of 20 kg and block 2 of 5 kg. And let's draw the forces. Here we will have the weight, of course, and also the tension in the string. So the tension in the string, and here we can write the weight, m2 times g. Now let's do the same thing for the other block. Here we have the block. Let's copy it. Okay. And we have, of course, we have the weight also, the reaction of the surface, and the force due to the string, or the strings in this case, because here we have one string and here we have two tension in the string, and here two tensions. So we can write here 2 times T. Let's all put it in red and also in red. It's better. Okay. And M1 times G, the weight, and here the reaction of the surface. These vertical forces won't interfere in the movement in this case. So let's write the equation of the movement. For the block number 2 of 5 kg, we will have the tension. Let's use blue. The tension minus m2 times g, the weight, equals the acceleration, the mass, m2, times the acceleration, h2. And for the block number 1, we'll have 2 times the tension equals the mass times acceleration. 2 equations and 3 unknowns, the tension and the accelerations. To solve the problem, it's necessary another equation, and we can find it looking at the problem. We know that the blocks are connected, so the acceleration of block 1 is related to the acceleration of block 2. We can write that the acceleration of block 1 equals the minus, because here we are considering vertical positive to going upward, and positive here is going to the right. So we can write that the acceleration of 1 equals minus a2 divided by 2, because here we have one string and here we have in fact two strings. So when we move this block, for example, 2 meters downward, these blocks will move 1 meter to the right. Okay? We can solve in the future a problem using many pulleys to address specifically this question relating this type of movement. Okay, so we have this relation between the accelerations, so it's easy to solve the problem. We can start from the second equation and write that the tension T equals M1 multiplied by A1, that is minus A2 divided by 2, this divided by 2. Therefore, we will have here the tension equals M1 minus M1 A2 divided by 4. Now, substituting the tension in the first equation, we will have minus M1 A2 divided by 4 minus M2 G equals M2 A2. Therefore, we can write that M1 divided by 4 plus M2 multiplied by A2 equals minus M2 times G. Therefore, the acceleration of block 2 will be minus M2 times G divided by M1 divided by 4 plus M2. This is the acceleration of the block of 5 kilograms. Let's use our numerical values. A2 equals minus 5 kilograms multiplied by 9.81 divided by M1 20 divided by 4, so 5 kilograms plus 5 kilograms. Therefore, A2 equals, let's use our calculator here, we'll have 5 times 9.81 divided by 10 minus 4.91 meters per second square. Okay, this is the acceleration of block 2, 5 kilograms. The acceleration of block 1, we can copy this, and here we'll have acceleration of block 1 will be minus 4.91 divided by 2, therefore A1 equals divided by 2.45 meters per second. Okay, here we solved item A. We found the accelerations. B, we want the tension. The tension, we can use this equation here. item B, tension equals minus 20 multiplied by minus 4.91 divided by 4, that is, tension will be times 20 divided by 4. This equals 24.5. 24.5 newtons. This is item B. And here we have all the problem. Very interesting, very instructive. And that's it. The problem is solved.